Hello, good evening everyone. Thank you for being here this evening for the closing event of Crossing Wires. My name is Camila Colombo. I am the co-founder and co-director of Ohme, which is a platform dedicated to the exploration of today's complexities through art and sciences. We do many different things, spanning from support to research and production in artistic research and production, and educational programs, outreach events, all stemming from the conviction that because it's complex doesn't mean it's complicated. Our activities span from educational programs to exhibitions, and a growing part of what we do is articulated around artistic residencies, inviting artists into research labs and institution to foster this idea of transdisciplinarity, which is very dear to us. We do this while supporting technically artists and designers in research and development for their projects. In 2024, we initiated a program of artistic residencies here with BrIAS, the Brussels Institute for Advanced Studies, and it was a blast. These 2 years around sustainable robotics and AI and automation have been really the marriage of these beautiful ideas of research free of constraint and dogma, in which we really, find ourselves and the spirit of Ohme. We are super happy to have you here for the closing event of Crossing Wires. So I'm really sorry, but you will have to bear with me a couple of minutes while I roll through my long list of thanks, because they are really heartfelt and very, very much necessary. First and foremost, we want to thank Anja Garone, the manager of BrIAS, for this absolutely great collaboration. She's been absolutely key in making literally everything happen, and she's truly a magic hand on everything she's touching. Andreas, you're in the back. Andreas Thank you for your technical support, because without you, all these things will be happening only for the people in this room. But thanks to you, you're the window on the outside world with all the technical stuff and the streaming and everything. So thank you for being here and dedicating us your time. Thanks to the BrIAS director, Frank de Koning and Serge Joman, for their trust in us and for letting us opening us the door to develop this residency program. Your trust is extremely precious, and we wouldn't be able to do this without us. So thank you again. Thank you to the program directors now, Professor Emanuele Garone and Prof. Annove. Their valuable support and guidance has been extremely precious for the artists that we've welcomed during these couple of years. We want to thank Innovatis, the Fédération Wallonie Bruxelles, and the Commune d'Ixelles for their financial support, which, is kind of necessary for making these things happen. And of course, now the long list of all the speakers that were with us during these 3 days. Professor Sarah Howard, Professor Jo Thunder, Professor Hector Enriquez, Professor Willem Zuidema, Marianne de Heer-Kloot, Antoine Bertin, Professor Antoine Toivonen, Professor Gérard Wiggins, Yannick Jacquet, Yael Edan, that's with us, for their inspiring talks. And of course, thanks to Guillaume Slizewicz, thanks to Kris Verdonck, with us, to this company, and thanks to Dewi Brunet, who are the 3 artists that have been in residency with us and BrIAS over this past couple of years. They are going to talk about their projects tonight. So, thanks. Then, of course, we have a series of little hands that are invisible, but crucial in making things happen. So thanks to the actually four magic helpers that held the bar and made sure that everything ran smoothly outside of this room, Valeria, Sophie, and Liliana and Anastasia. You see behind me a bit of little mysterious setup. After the talk, we're going to have a live performance of Portaitic So I want to thank her before her performance, but she's going to give a live performance of her show, The Cost of Connection, and this is going to be quite mind-blowing. And last but not least, thanks to the team of Ohme for the very, very, very hard work. Raoul, Chloé, Gwen, Thomas, the other Thomas, Nicolas, Andrew, and Ophelia, thank you very much for everything you do. So without further ado, after this very long list, but very necessary list, I would like to welcome here Anne, co-director of, program director of BrIAS, Guillaume, Yael. We're going to switch presentations, and to split the presentation. Guillaume Slizewicz has been in residency with BrIAS here over the past 6 months. He's an artist and researcher and a designer, and he's going to tell us about his project, giving it a bit of insight on carbon technostructures and the reasoning behind it. Thank you for being here.
I think Yael will start, right? So it's a great pleasure to introduce to you Professor Yael Edan. She's an expert in robotics and intelligent systems. She's also a faculty member at the Ben Gurion University of the Negev, if I pronounce this correctly, in Israel, where she leads a team who's doing robotics, human-robot interaction. Her work is very interdisciplinary. It connects to computer science, engineering, AI, but also to art. And this is exactly what we went this evening. I'm very curious to see how you manage to deal with all these disciplines. No, you should not. I'm sure you can do it. That's why you invited you, and we're eager to listen to your story. The floor is yours. Yeah.
Thank you very much. I'll try to present today a bit of how I link. First of all, I'm totally out of my comfort zone. So I'm a hardcore engineer, computer engineer by training, master's in mechanical engineer, and a PhD in intelligent systems, electrical engineering at Purdue. So nothing to do with arts. We're trying to link with arts, and I'll try and show you some of the problems as an engineer, some of the gaps, some of the efforts that we have done. So first of all, regarding myself, my basic expertise 35 years ago and continuing on, I've been working on agricultural robots, a lot of intelligent systems, systems engineering, bringing things together, bringing them to work, bringing them out in the field, and we have significant developments in this area. From the area of agricultural robotics about a decade ago, I realized that in order to make a full autonomous system, get it into the field and work in the tough, complicated environment where nothing is unstructured, you cannot model anything, it's almost impossible, and you need the human in the loop. And then I started to work and look into how do you get the human into the loop, and worked a lot on different models for human-robot collaboration, levels of automation, a lot of work on human-robot interfaces, human-robot cooperative learning, and so on. The link to this presentation here on creative collaborations, art, design, and human-robot interaction happened when I founded about a decade ago the ABC Center, Agriculture, Biological, Cognitive Robotics Center at BGU, at Ben Gurion University. And the idea was to follow ABC, aspire, aim, achieve, and do exactly what we want in the creative collaboration. So break the ice, bridge the gaps in order to create creative collaborations, in order to create innovative multidisciplinary robotics research. So the aim was really to advance theoretical foundations by bringing in different and new disciplines and not the traditional. So we're doing a lot of the basic robotics research in all the aspects of ground, aerial, underwater robotics, agricultural robotics, intelligent robotics, service robotics, social robotics, and working on designs, which I'll focus mostly today. Motion control, intelligent sensing, planning, won't show you anything of this. Human-robot collaboration and multi-robots. And we try to bridge the gap by bringing in and putting together all the traditional engineering, computer sciences, which is, of course, trivial and an important part of robotics, but bring together cognitive sciences. That was quite easy. Bring together psychology, bring together medical sciences, life sciences. That was also easy. And also try to bring in the more faraway disciplines, social science and arts. And we're just starting there, and that's why this area here at BrIAS has been really, really a strong and inspiring effort for me. So I'll just go through the ABC and show you a sample of different ideas and different focus. Agriculture, as I mentioned, we're doing a lot of work on agriculture and have developed a lot of different systems for site-specific spraying, for harvesting. All the systems have been brought out to the field, are working. We have proven feasibility. We have advanced sensing, intelligence, and so on. And most of the systems are not commercialized. We're still not there because of the complexity, because of the lack of robustness and reliability, and because I would say lack of design, which I'll show you later on. Arts. Arts we see as a very useful perspective to approach robotics. Design is a crucial aspect, and I'll show you some of the ideas we advanced in design, and I think that's where we really need to make more if we really want to make a breakthrough. Human-robot interaction must be interactive, must be engaging in order to get the people in the loop, and that's where we need this gap to overcome and get together. Interactive arts can give a lot of input into interaction and design, and I'll kind of show you some directions. The most research that we advanced in the link with arts and with a very strong faculty member in arts, but in historical arts, was basically in the design aspects, and that's where we focus. And again, that's part of a comfort zone because we are in industrial, I'm coming from industrial engineering, human factors, and that's an area that you can go. But really by emphasizing the wide world of shapes and changing relationships, I think that's where we can make the next stage and the next step in robotics. And HRI in art can really contribute to practical designs by providing an enriched environment and new ideas. This is some of the work we did. So we did basically try to make a design of robots, new ideas, getting the human in the loop and involving the human in the loop. And for an example, social assistive robots for older adults, we have designed a lot of different prototypes in different types of applications. Of course, all the algorithms and everything, but the design is a very important aspect. We have developed for educational purposes a system, and again, the design was very critical in order to get the students, the children, attracted. A very simple procedure. Along COVID, we needed an officer to guide the students' environment when it was already a bit open and to make sure that everybody had masks when they were going around campus. And just the design of the robot made a difference in how the people respected that robot officer, were surprised from that robot officer or not. So basically, the robot's appearance affects users' perception. The social assistive robotic design is context-driven, so it depends if it's a robot for social entertainment or if it's a robot for social security, as you see here at the bottom. Different aspects of the robot affect the user's perception. It's driven, we did many different experiments in Germany and here in the Netherlands, and the outcoming robots are totally different designs. And of course, a major effect by personal preferences. So we do call mass customization. We should make the robots be personalized to each specific person. History of robotics and arts. We can learn a lot from the technological development of robots and we can learn a lot of how robots have developed. And actually, I'll soon show you some of the developments, but we are stuck way back from the initial thinking of robots from science fiction. So the history of robots really combines really a lot of science fiction, a lot of the entertainment, but we have not advanced. So we've advanced a lot in control theory, in algorithms, in sensing. In the design, we're not there yet. So again, the idea of robotics was invented way back by a Czech theater in 1921. 1942, Isaac Asimov made the big difference, and this was before robots were actually out there in the production. Well, we can also state that the first robots was designed by Da Vinci way back in thought at least. However, as you see here, and I'll show you soon some additional, the robots have developed a lot in sensing and in control. But if we're looking way back, and these are the first, before the first robot and was introduced into industry in, if I go back, in 1959. Okay, that was the first robot that was actually working. And then a bit later, that was the first manipulator that was working. And then in 1960, the first mobile robot, Shaky, by Stanford University was put in. And only way later, in the 70s, were the first programmable, really actual robots brought into industry. But if we look back into movies, into science fiction, the first Machine Man appeared already in 1927, okay, way before we had all this technology. The robots, and these two robots, Gort in the movie The Day of the Earth, and Robbie the Robot in Forbidden Planet, 1951, 1956, it was before the first robot came into actual practice, okay? Marvin is already a robot that was programmed, that was brought into movies way after robots had actually appeared. And actually, the only new really idea came from Space Odyssey in 2001, where the robot is basically a simple design, okay? And here I start seeing some of the arts. A disembodied robot voice and a light, and that's it. And that's what catches the people, and catches the movements, and catches everything. Now, if we look a bit forward into all the amazing mechanical, electrical, intelligence, computerized, humanoid robots are today, they all look the same. They're very similar to what was way back in 1927, and we haven't changed. We haven't made a big leap forward. So where and how do we bring in these arts in order to get this into practice? I won't go into the link between art and robots. We had a fascinating talk yesterday on discussing creativity. Is arts made by a robot creative? I think what we are lacking in the robotic science is the creativity, okay? And there's a big gap there. And therefore, I'll go a bit and show you different aspects where we learned a lot about in robotics from nature and from biological, okay? But I think we still needed to do a lot to bridge the gap. So when we're discussing with, yeah, so we can see the movies here. Okay, so in order to make and bridge this gap, we need to explore different robotic designs. And what you can see here is creativity of one of our young professors, who's really designing innovative new and robotic designs. And that's what we need. And that's where we can get inspiration from the arts. Okay, we do also need a lot from nature, and we learn a lot from nature. So this is an example of two different projects. On the right, one of the major sensing in robotics is based on, as humans, is based on visual sensing. However, we need also additional sensors, and we can learn a lot from nature. The rat is one of the most famous, fascinating navigating animals. The whiskers, each whisker has different physical sensing abilities, and along the whisker, the physical sensitivity changes. So if you can design a sensor that has these dynamic influences and changes, you can make a difference. We linked here together a computer vision expert with a life science expert. The fish is an amazing, very primitive brain. Despite this, is able to catch any prey. So what we're trying to learn here is study the primitive brain of the fish in order to maybe design better robots. I'm coming from the field of agriculture. We need imagination in order to create new designs, okay? So if we want to make a leap in this field and if we want to make it practical, we need new designs. And we need, in order to get new designs, one of the important issues is the link with out-of-the-box people from different disciplines and so on. Regardless of these new designs, everything has to be as simple as possible. As an engineer, yes, we can do a lot of complex control and everything, but if the mechanics are not simple, it won't work. So we need, and you see here an example of a snake robot, you see an example on the top of a Spider-Man robot, and you see an example here of a snail robot. The principles, the operation of the principles have to be very simple if we really want to get this to work. And therefore, we need cognition, but we also need creative collaborations. So in cognition, we have been doing a lot of work on man-machine brain-computer interfaces and algorithms. And we had here a talk before discussing on the human driver and involvement of control and so on. I guess my most fascinating is really imitation learning and how we see young children learn to dance ballet. To teach a robot to dance ballet, yes, we can do it. And yes, there has been advance, but we're still very far away. And I guess a big inspiration, here you can see some of way back Japanese robots synchronized in dancing. But I invite you all to look at the movie by, the work by Dr. Marit Moore, a quantum physicist and a professional ballet dancer who, along COVID, started dancing with the robots and opened up to her a whole great, very important world, and saying that you must push the boundaries. You must merge technology and art. And it's really a huge opportunity. So there is an advantage also to technology, bringing in technology into arts, and we'll hear some more of that soon. But there is an advantage of taking the of pushing into technology some ideas from the arts. We've been doing a lot of different strange things, such as using robots for archaeological, a huge EU project in which they're using robots to try and put together the different pieces. So a lot of sensing, a lot of planning, a lot of learning that goes in there. As I mentioned, we did a lot of work on trustworthy design for social assisted robots and trying to bring in robots. And basically, I think the way to really advance in robotics is really, we need these creative collaborations. We need the link between art into HRI, between design into HRI. What we have done until now is quite limited. So it's at the design aspects and I would say industrial design. Some connections with art. The biggest gap at the beginning was we're speaking different languages. So we have to break the ice in order just to start talking together. So we're talking, but we're still not really working together. And I sure look forward to enhance this bridge, which must be advanced. And I think that in order to get into the next generation, and we were talking yesterday about AI in education, I think one of the main aspects would be, how do you introduce creativity? So I think one important aspect of engineering would be to teach them arts, not only AI and all of these tools. So thank you very much. And
thank you.
Lots of cable. Ta-da, c'est beau. That's not what I'm gonna show. Oops, sorry. So you're seeing all my presentation in reverse now. Okay, first of all, thanks a lot to the organizer. Thanks to BrIAS, the whole team, and thanks to Ohme. It's been a really good last couple of months. I really enjoyed it. And today I'm going to speak a little bit about first the residency and maybe being in contact with scientists, and then more about the project I developed in the past months. I might just put a timer just to make sure I don't go over time. Okay. So I'm a designer and digital artist. I work with many mediums. I work with metal, with ceramic, with wood sometimes, but I'm mainly interested in finding poetry and evocation, in working with machines and algorithm. So most of my work is in relationship with a technology or a tool. For instance, for this called tablets, I use the library, a scientific library called GraphViz, that is usually used to draw correlation, causality between different things. And here we use it as a meaningless correlation between different shapes. It has this nice as well archaeological thing that it's in ceramic, whereas usually it's on screens. This is another work that I did that is currently on display in Leuven, where I use diagram from an archaeogeologist, I think that's what it's called, and trying to also work with ceramic to put them to kind of make the loop, so they get their ceramic, they study it, they make diagram out of it, and then it goes back to the ceramic. I also like to explore the tension between technology and sustainability, and especially between innovation and sustainability. And this is really linked to what I did here, which is sustainability was one of the key aspects of the program. For instance, this is Canary. This is a lamp that translates air quality, open data into light patterns. And what's maybe more focused for here is I like to use science as an inspiration. And this is why it was great for me to be here for a few months. So thanks again. And it was, I must admit that it was not easy every week to follow and to understand, because sometimes you come and you kind of get the grasp of it, the gist of it, but sometimes you're faced with this kind of slides. And I have no background in electronic engineering and no background in computer science, and you're like, okay, maybe I won't get the full extent, the full breadth of this lecture. But it was full of idea, inspiration. It was really triggering for me. I mean, a few highlights of me were the lecture by Rodolphe about physical computation and neuromorphic computing, which I didn't know and which I found really, really interesting. Basically, from what I understood, it's the idea to kind of mimic the activity of neurons in order to decode the data from sensing systems. It's a bit between analog and binary. That's what I got from the lecture. I mean, more of this, but the summary. And then the state of robotics that was explained by Bram in one of the week as well. The talk by Yael was really interesting as well about language, but there was I couldn't find the YouTube, so there is no image for this. But what really shocked me, and I mean, not shocked me because it's not the first time I work with scientists, but you always find a lot of similarity between artists and scientists. Curiosity is probably the main thing, and creativity as well. You have a lot of creativity. And sometimes you do things just because you want to do them. For artists, it's in the name of arts, but for scientists, in the name of science. But sometimes it doesn't have a direct application afterwards. And I find that quite beautiful that you just for your, as a bigger ideal, or just to have this kind of satisfaction, neural satisfaction of discovering something or creating something. But there's also different types of aesthetics. For instance, I was really taken aback when there was this presentation of modelization of turbulence for wind farms. And I think this modelization could be in an art gallery. I mean, this is really like this 3D modeling of turbulence is really actually quite pretty. But also you can see as well aesthetics in this type of diagram where you try to explain something really complex through graphics and through images. But I think as well, something that is not bothering me, but I find really interesting, that science is seen as a way to explain the world, to make it more intelligible, to understand the world, but it's a very esoteric practice. So if you're a layperson like myself, if you come to a seminar, most of the time you don't understand 90% of what is said. So there's this kind of cryptic language, cryptic diagrams, which as an outsider can be really inspirational. I just took the last diagram from the last paper on archive, and this is supposed to make it more intelligible. But of course, when when you come like to this, you like by itself it doesn't say anything. So this kind of like this diagram being seen as a way to convey information, but actually they don't convey a lot if you're not in the field is something I find completely a bit absurd, but in a beautiful way. And that's so I'm reading this book at the moment, and he has a saying. He's saying this the gospel of science. And I also have another project where I work I've been spending a few days in a laboratory, and there is something a bit religious about it, but I don't see it in religious in a bad way as some people might say it, but as religious as there is a liturgy, for instance, to lab processes, and there is a kind of a like we call it seminar, but it's kind of a monachal like monks gathering, or some kind of theology when you think of that. So I think that's quite interesting as well. So that was a good experience here. But I came here as well with the goal of developing a project, and the theme of BrIAS was Sustainable Robotics, AI and Automation, and this was really in line with this project. This project is called Carbon Technostructures. Oops. And it's made with Rais de Hai, who's not here today, but who contributed to the project. And basically, in broad strokes, it aims to analyze, to investigate the carbon impact of our digital lives. And I'm going to drink a glass of water. So what impacts? I mean, probably most of you are aware of, like every time you use the cloud, you're actually using someone else's computer. That's what the cloud is. There is no cloud in the clouds. Actually, it's all lots of racks of servers and either GPUs or other electronics. And whenever you access this server, you actually use roads, electronic roads that are starting in Belgium and then going to the server. It might be in the US, mostly in the US, or somewhere else in Europe. So you connect to a website, you go through all those different little piece of infrastructure. So you have a lot of different nodes, and then you reach your data center. And in Belgium, we have one of those nodes. It's a Belgian Internet Exchange in these beautiful buildings in the suburbs of Brussels. But we find it's really interesting to see the materiality of the internet compared to what's sold on the internet, so what's sold as the cloud. Actually, it's an old 80s building in the suburbs of Brussels, but you see it as something much more romantic when it's sold to you, and when it's explained to you. And it's also relying on a lot of electricity, not only to make those electronics work, but also to create them. And we love working with this tool, which is a map of electricity in the world. And it's in real time, I think. And it just gives you the intensity of the grid at any moment. So in Belgium, at the moment, we're doing a lot of wind and solar energy, a little bit of nuclear, so our carbon intensity is not so big. Of course, it's about carbon, so nuclear has other problem with nuclear waste and so on, but here we're talking about carbon. But you can also see the different exchange between different countries, which is really important in Europe, and see a bit the geopolitics of carbon accounting and also carbon measurements. I think this this is an aggregator, so this kind of data is possible because the EU has strong rules about actually releasing the energy provider have to release their data about what they're going to produce in order for them to be able to control the grid, because you don't want too much electricity at some point or too little. The question, you have all this data about electricity, but then all about the grid, but how do you translate them? One of our first things we tried, it's a little plugin that you can put on your website. It's called Carbon Aware. I don't know. Yeah, and it's basically a visualization, abstract visualization of something at first you don't really understand. It's the energy mix, and then we explain to you what is it actually. It's the energy that the server and you are depending on for accessing this website. For instance, here the server is in France. France, a lot of nuclear power, a little bit of wind, a little bit of solar, and some hydro, because it's in Clermont-Ferrand, so near the mountains. Brussels, nuclear, wind, and solar, and a lot of gas, and some that we don't know. And that's most of the case in most countries. You have a big part where you don't know actually where the energy is coming from. And those maps are really good only for, let's say, Western countries, because otherwise you don't really have the data. Which is a recurring theme in researching the implication of the communication, and especially the environments. But we are thinking about how to represent it, and we really like this kind of apparatus. It's like seismograph that you can find sometimes in museum to kind of make you aware of seismic activity. And we really like those paintings by Johan Meulenbeek, I think it's called, where you have this kind of steam system. So we developed we called it first a cloud plotter. I'm sorry, usually there is sound, but there is no sound here. And basically we put it in cultural venues, and we are calculating the carbon impact of the venue website in real time. You have a little Raspberry, it just creates an API call, and then to plot it, we use steam. So basically, as you can see here, there's a little layer of steam, and then it will write something with an empty marker on it, either some abstract representation of the carbon impact, or sometimes something more pedagogical, so just saying the carbon impact is thus and thus gram by CO2. Yes. Oops, sorry. So that was the first installation. So it was more about website, about the internet, which is kind of the ancestral digital life brick, let's say. But for this residency, we really wanted to focus on AI, because it was also in the title. And so we think about how we get from website to AI. So AI, you have two main ways to consume energy. First in the training of models, and then in what's called the inference, so whenever you ask a model for an answer. Of course, training costs are really big, but it only occurs once, and inference are usually smaller, but they occur many, many times, millions, billions of times. So actually, no, they think that both of them are more or less the same in the end. But we are aware that the cost, actually, the impact of the carbon impact of this technology is not so big. If you look at last year, the journal articles, it's just a one small part of data centers soaring energy use. It was only 9.5% of projected electricity demand for the entire world in 2024. And it was less than crypto and less than video games, which really surprised me when I first saw that. Because that's, when you read the news, you have the feeling that AI actually is consuming much more, but we don't talk about crypto, we don't talk about crypto anymore, we should, and we don't talk about video games. But we are aware that it's also massive. It's really, really big. So, and it's like we see that Elon Musk is building what's called hyperscaler, so really big data center, and it doesn't have enough energy on the grid, so he just brings some big gas energy generator. We know that there's a massive other problem like e-waste, or we know that in order to build a data center, you need hello, you need billions of tons of concrete. That's my daughter. That's why. And we saw that it's also we had also a lot of geopolitical consequences. So in the summit for AI, we had Macron saying, "Hey, you should come to France and use our beautiful nuclear energy." It's also growing. Yannick made a really, really nice talk yesterday about a new video generator from Google. And we know that, for instance, text is much easier to generate than video. So those video generators are probably going to consume much more energy than the text model we have now. And we're also not quite sure. That's the main problem, is that we don't know. We don't know for sure. So we have a lot of estimates, but all the big players, they don't release their data. So we don't know. There's a quite good article that was released a few days ago in, I think it's MIT something, Technology Review, yeah, exactly, MIT Technology Review. And I encourage you to read it to have a more nuanced research on that. But here in BrIAS, we did a carbon technostructure, and it's going to be the end of my talk, focusing on the GPU, which is the basic block of those models. And we run a small model on a local GPU, and focusing on large language model. And we ask it to to generate a drawing that we plotted as well on this cloud plotter, and we calculated. So we asked a drawing of the energy consumption of the model, but of course the model can't know its own energy consumption. So it's only fabulation, confabulation, dreaming, hallucination, call it what you will, but it's only abstract forms. But what we did is that in the same time we measured the GPU energy while doing it, so we could have an estimation of the carbon produced for each drawing, and that's what I invite you to come and see afterwards. It's in the back. And that's it. Thank you very much.
Thank you. So now we will have a short panel discussion with our two presenters. I see some chairs are being moved. Thank you.
Yes.
Yeah. Thank you very much. So maybe a first question I want to ask actually to Guillaume, because Yael, you explained a bit to us during the talk how you reached out to art, also biology, and indeed biology can be very creative as well and inspiring. But Guillaume, I would like to know how you got, how you reached out to algorithms, or what made you connect to algorithms? Because the reason why I'm asking it is it doesn't seem like the most sexy topic as an artist to do. And maybe I can start with a little story about myself. So I studied mathematics, and the reason why I chose mathematics was, well, I was good at that, but I also felt very comfortable in my real abstract world. And I took mathematics with a minor in computer science for two reasons. One, that it opened more job opportunities. That was one reason. But the other reason, and that's why I want to mention it, and I'm talking about the late 80s here, is that it was like more acceptable, more in amongst friends, let's say, so socially acceptable to study mathematics if you combined it with computer science, because computer science at that time was considered to be more sexy than today. Today, it's really only about nerds and people who don't connect to other humans and are just programming in their cellar. So the perception was very different. So I would like to ask you, how did that happen in your case? This connection to technology, algorithms, especially algorithms that you're using. Yeah.
So I have a background not in classical art per se. So I did first kind of humanities, and then I did what's called production technologies, which is a bit more industrial design, let's say. Mm-hmm. But I think I came to algorithm through more, let's say, graphic design. So algorithm, I got them through first websites, and when you code website, then you get like a first coding language, which is not a coding language, which is HTML. And then you get to CSS, and then you're more interested maybe in JavaScript and Python. And then you realize that you can actually use tools that use those language. For instance, I mean, I use CNC, I use laser cutters, and in order to make patterns, you like to use those language. But also you learn a bit how you can generate things and generate patterns and generate also art or different aesthetics things, and that's how I first got in. And there's also the social part of it, which I was quite interested quite early in, how it impacts society. That's something else.
And how was that perceived amongst your peers? This interest, this move.
I don't know. I should ask.
You
But
didn't care.
no, but I think because my studies were in the end of the notice beginning 2010. So at that time, like data science was coming in, and I was really excited actually about using data science and using machine learning, what was called machine learning and not AI at the time, for production or for artistic purposes, because it's a new tool. And in the history of art, you also have this thing: when you have new tools, you have new possibilities. I mean, like the electric guitar, or like when you have the paint in small things, so you can go outside, and then you have the impressionist wave, and then you have the electric guitar, then you have rock and roll. So whenever there's a new tool, you also have a new aesthetic language, and you can have exciting things happening.
Okay, thank you. And maybe you said very explicitly, I'm a scientist, but as a scientist, we also need to get funding to realize our ideas. Did you find it difficult to get funding in such an interdisciplinary context, especially if you then want to involve artists? Was this challenging to convince funders to believe in that?
So first of all, the overall perspective of the ABC, we got funding because of the bringing together.
Okay, so it was
So that
considered
was
to
the
be
basic.
positive, yeah?
And then the second work that I showed you, some of the design work, we got from our Ministry of Science. So it's a very applied, but they were looking into new ideas.
Yeah.
And they saw this as an interesting aspect, how to bring in and combine in artists. So we were working actually with I wouldn't say somebody from the Faculty of Arts, but it's more history of arts. And then we, through them, got connected with the School of Industrial Design, where we did most of our work. So yes, we got funding. It requires open people, open-minded people, and it really depends. But
okay, thank you. We'll invite also the public to ask some questions. I'm sure that some people have also questions for our panelists here. So if you have a question, please raise your hand. Yeah, Frank. I don't know if this.
I don't know whether this works. Yeah, it works. How do your colleague artists look at you when you tell them that you work in the relation between arts and science?
I'm maybe not the. So I don't. I mean, I don't know if I have so many artist friends in the classical sense doing like only sculptures or only paintings. I mean, most of my friends are also quite interested in art science collaboration or in technology, and also I have other science that are in completely different fields. So I think the most challenging thing is explaining what I do. I think that's the most challenging. But apart from that, I don't see they see it's morally wrong or morally good. They don't care. Yeah.
And is it difficult to realize your ideas? So at the end you also need
support,
financial support.
That's what those type of residency are really important as well. Yeah, you do. But also, I mean, in terms of that's also something that you need to be aware of. Yeah, it's not always easy, and some ideas are easier to implement than others, but it's a bit like research funding.
yeah. That's why I'm asking. I can imagine that it's quite similar. Yeah. Okay. Other questions? Don't be afraid. Ja, sure. Wacht,
ja, no, het is oké. Ik kan luid spreken. Ja, dat is oké. Ja. Ja, oké. Well, are there kind of people interesting about your art? Is there a market for this?
So that's a really interesting question. So basically, I've been, let's say, active also. I've worked in different fields in the creative scene. So you have different ways of financing your project. So if you go to the contemporary arts, it's a gallery. You go to a gallery and you sell. And you're not paid to display your work. You're only paid if someone buys your work. So that's one way of and contemporary art is usually like this. in the digital art, it's very different, because digital art is really hard to collect and to display most of the time. It needs a lot of maintenance, and it's really hard to. It's not a good investment, basically. So you're often paid to make the work, and often paid to display the work. That's a different way to do it. So it depends on which field you're going into. And then you have art science, which is again a slightly different one. That is, you mostly paid to do the process with scientists. So it's different way of funding the work, and you have to navigate your way through this.
Yeah, and it's very interesting what Guillaume is saying, and I would like to build on that. The art market, as is generally conceived, is just a market that has its own rules, but that is a market. It's a marketplace, and it's based, unfortunately, a lot on the concept, the idea of financial investment. So, and as every place where there is a lot of money that is moved back and forth, it functions following criteria that are not necessarily the one that let's say are at the root of artistic creations. For digital arts and for arts and science, as Guillaume said, there are different rules applies. It's very difficult to find gallerists and collectors that have the means or the culture or the interest in investing in this type of works. There is more and more, but it's just even the biggest institution like the MoMA in New York are just starting now to question themselves how to preserve this type of work. Because, of course, every time that there is a technology, at the pace that technology evolves today, artworks are obsolete in a snap, and the MoMA invested in, I don't know, hundreds of thousands of dollars in buying old TV screens or old computers just to be able to run artworks that were created in the 80s or in the 70s. It's of course, it's not something that is for the pockets of the the average private collector. But it's interesting. It was a long diversion to say that when there are interaction between art and sciences, we're still talking about a niche in the contemporary art world, and the accent is a lot on the creation process. So it's not much about what is produced, it's not much about the final output, but it's very much about the process. It's very much about the time spent together and about the mutual influence between the artist and the scientist involved. And we live in a world that is extremely complex, but we keep trying to find solutions that are extremely sectorial, which feels a bit bizarre, to say the least. And that's why this type of cross-pollination are extremely important. Voilà.
Thank you. Oh, there's a question in the back. Yeah.
Hello. This is like a bit outside of like the more scientific and artistic part, but I would say that it's more linked to the artistic. But for Guillaume, most likely, like I see that, okay, you have both interests, but what are you trying to put forward as a message? Because I see first you put like a bit about the sustainability side, but what would you like as an artist to put forward that you really want to reach, like not only like civilians or whatever people that are interested in both art or technology, but what is like your final message, like your purpose that you try to reach with your art? Because you're trying to connect two worlds that are not that easy to connect, but you still manage to do it. But how would you try to target those people that, as you mentioned before when you attended some of the seminars, you just feel like, I don't understand this, like this is not my language. As I was say before, like this is like Chinese, but this is not even Chinese, this is computer language. Like what do you want to do? Like regardless of the sustainability, because sustainability is very important, but what else do you want to push into these people to make them conscious about it?
Good luck, Guillaume, answering this question.
So I think there was different aspects in your questions. The first one is how do you connect with people that are scientists that are really niche focused? I think it's not a problem when you talk with people one-to-one, and in most lecture, people actually you get something of it. And also, I think for me, these seminars were a way to it's like when you're learning a language, you get an exposition phase where you don't understand anything, but you get more and more words and more things. And that's the process you need to go through a little bit when you touch on a new subject, which is, I guess, normal. And then when you talk with people one-to-one, they usually are able to articulate what they're doing in simple terms for lay people. But that's also interesting to experience this kind of distance. And I think your second question was more about awareness and whether there's a awareness part in my work. I do feel there is. I mean, the main driver for me is maybe not awareness, but maybe more curiosity and understanding myself. And also a big part of it that is sometimes a bit, but not forward in art science especially, or sometimes in digital art, is just the aesthetic value. And this is because it's at least on par with the more like awareness. It's like just do things because I'm curious and I want them to look good and I want them to be enjoyable, to have kind of a aesthetic shock or aesthetic value to it for themselves. Just like you're doing science for science, you're doing art for art. I mean, there's a part of it. And a part of it is obviously reflecting on the societal change that are happening.
Excuse me, can I ask a question? I found in the PowerPoint that there are unitary robotic. Yeah, I know the robotic and the arts. I know the unitary robotic. Then can dance. Yeah, it is in this new year. It is a very popular in the net. They have a popular dance where it is robotic by the unitary. And this first question is, what do you think about the robotic, unitary robotic, the difference from others? And the first one is, I know the AI that is popular now, but also in China it is very popular. We have the DeepSeek. I'm not sure if you know the DeepSeek. So I want to know what you think about the DeepSeek with ChatGPT. What do you think about them? Can you talk about something about that? Okay, thank you.
So regarding the unitary robot, yes, it's fascinating mechanics, fascinating AI, and there we see a bit change of concept from those humanoid robots into these. But again, it's from nature. It's a dog kind of robot without the head. First of all, it's very, very complex, very, very expensive. So it's technologically perspective, from an engineering perspective, it's wow, but will it get out to actual daily usages? I am very skeptical. First of all, because of the complexity, not only the price, the complexity and maintainability. So yes, from an engineering perspective, it's a wow. From a practical perspective, that it will get robots into we need things that are simple and working, and I specifically, AI, yes, it will advance. Will it be able to make that leap of creativity in design? I'm not sure. So it can advance. It advances the complex systems. We as a society, we need simple solutions. So a bigger breakthrough, to my perspective, was the Roomba vacuum cleaner. Simple and works and cheap. Okay, so, but I'm an engineer, not,
Yeah, also social robotics. So what I was missing a bit in that, it's an impressive act, but there's no human-robot interaction. So, and I think that is a challenging thing if we want to go to the real life through useful applications, right? I see some question over there.
Just to answer on DeepSeek, yeah, I think most researchers in the seminar were aware of that, and we're actually using DeepSeek for installation. You have a lot of caveat around it because it's partly open source, but partly you don't really know how it's been trained. It's always the same thing, but at least you can use the model.
During your presentation, you were talking about science fiction entertainment. So things that were science fiction in the past are now reality. So how far do you see the boundary between science fiction and the reality now? It's an open question.
I think we should learn a lot from science fiction and from people thinking, not from our engineering and computer and AI box. So people thinking, and that's exactly what I showed. So people were thinking about the robots before we even had the possibility. And that's where I think so the ideas, like I showed you the idea of in the space odyssey of just that blinking eye, which communicates and which is fun and which is, so that's where we should inspire ideas from. And of course, we need the complex engineering and we need and there, by the way, AI won't, okay? You need the complex engineering and you should put aside the AI in those perspectives. You need to understand the physical elements and so on, and so AI won't solve all that. You need the dynamics, you need the systems understanding, deep understanding, but you need also to think out of the box and to get new ideas, and that's where, by the way, one of the most amazing robotics is go to Disney and you'll see amazing robotics in work.
Sorry, just curious questions. This one is for Yael. Because, okay, now that he talks about like the fiction and the movie industry, we can see that in the past, people tend to be more creative in that sense because we didn't have like much knowledge like internet to look up like what a robot is or anything. But I was wondering like if you have any sort of hypothesis like how scientists like researchers get stuck into the research phase and kind of lose on the creativity side. Like what is kind of like as you a researcher, let's say, make you restrain more like to your theoretical one, even if you're researching, into pushing the robots to look different? Like why did they, like what would be your hypothesis more or less, or just suggestions why people would think more like, yeah, they look like this is the creative of the past and we should stick to it. Like now they're a bit more like elaborated, but what do you think about it? Like what would then suggest more like to researchers like in your place, like because you're in engineering, but also like how to push more like artists to not be scared and really find this side into the scientific world like Guillaume is doing now and try to mix both worlds?
So I think, well, first of all, engineers really kind of got stuck and made a big advance in understanding how to make things work. So there's a lot of strong engineering creativity in developing the models and so on. In the design, I mean, it's kind of going in a parallel line. So you see from time to time new different concepts. I would say concepts, very few, not enough. And that's probably because of the typical engineering work. So as I said before, I think when you're talking about changing education and involving AI in, for example, engineering education or children's education, bringing in more creativity might be even more important than just teaching, from my perspective, teaching a kid music is much more enriching than teaching computer programming, which anyway, he'll learn the skills and he'll know. And
my question is, during these days, several people has talked about explainable AI. My question is, what do you believe about the role of the explanation in this context of interaction and human in the loop?
Critical, we're doing a lot of work. I didn't present anything on very basic work, okay, on human-robot interaction and understandable robots. So how do you make the robot understandable in a very simplistic manner? Again, I come from simple engineering and make it work. So how do you make the robot understand what the human is doing and the human understand what the robot is doing? Through human-robot interaction, I think that's critical. And it will be critical, because when a robot will always fail, even if we develop the best robot. And the human must understand why it fails, how it can help it overcome these failures, and their explainable. So that will make a big step forward, and is very important, and it's very critical.
Do we have any other questions? Yes.
Okay. I have a question each. First, there's a topic that you mentioned about the interaction between human and robots, right? How do you think this, to be effective for engineering purposes, how should this interaction be modeled, right? Because humans are very complex entities, right? So, and we usually have a reductionist approach, right, to interaction. So what's your view?
So it's very, very complicated. I mean, we started way back on trying to model just levels of automation. So how do you decide on the optimal level of automation? So when everything is working okay, the robot can work autonomously. And then on the other perspective, it can be totally teleoperated. And in between, there are different levels of automation. And how do you trigger the transfer between these levels?
So the question was not when the robot should be remotely controlled versus be autonomous, but if I'm interacting with a robot and I want this interaction to be meaningful and safe at the same time, what kind of models should a robot use of the human so as to achieve the goal?
So we're kind of using kind of mental models. So the robot tries to theory of mind. We try to develop, so the robot has the theory of mind of the human, and the human has the theory of mind of the robot. And we use different HMMs, Markov models. But again, it's trying to model. Okay, so it's trying to model what will be the next step and what will be the thought, and there's a lot of uncertainty there. So you do need the interaction to overcome these uncertainties. So the model is nice and it works, but it sometimes doesn't work. And then you need the communication. Okay, so the models work to some perspective. So you're able to model the different levels of what you think the robot is doing and what the robot thinks you are doing, and you measure this discrepancy in what you think the robot is doing and what it is doing, and try to overcome it. But you do also need the actual interaction.
For Guillaume, you work at the intersection, right, of science and art. Do you see common beauty primitives, if I can use the word, among the two?
This is a really interesting question, because I think you start from kind of beauty primitive at first, and then you add complexity, and each complexity is depending on the niche you're in. For instance, I'm gonna take an example from design. You have some practices of graphic design that really are quite, let's say, punk, or quite don't like white space, don't like symmetry, and are doing things that can be a bit brutal, but they like the aesthetic of that because they built a narrative around it, and it makes it enjoyable for them. And I think for science is the same thing. It's that you're in a niche, and then you get with your peers. I mean, art and aesthetic appreciation is also a social thing, and then you get different stimuli that are triggering you or that you find beautiful. And I think in science you also have something that is intellectually beautiful. That's something that you find when you get a shiver because you feel, wow, this is actually quite clever, or this is actually quite beautiful because it's presented in a way, or it's organized in a way that it sends shivers through your spine. And I think you can have that in different niche and different context.
Maybe I want to ask you also the question on So we discussed human-robot interaction, but there's also, I would say, human-art interaction. And then I'm inspired by this New York, Dublin portal, which was also supposed to be like some art connecting people, but people then challenge this kind of pieces of art. I would say, has something ever similar happened to you, to one of your art pieces, or the people interact with the art
yes.
in a non-intended way. Huh? So
that's always a possibility.
Yeah. So did something like this happen to one of your creations, or how do you try to protect your art from this kind of you could call it misuse? Or
I usually work with cheaper materials.
but still, I mean,
there's always risk for failure, and it's actually quite cool that there is this like unknown. I did actually some small robots that I could show you afterwards, and then you had they were really stupid in the way that they had just like an object recognition algorithm. That was local, and they were just following people and staying at a certain distance of people. And then, of course, then they run into a wall and then they're stuck. So you have to pick them up and put them down again. And then, so for really complex pieces, I'm usually there. And then yes, exactly. You minimize mitigating risk. It's part of the practice.
Okay.
And then you have like ceramic pieces, so that you can let them there and then they don't move and it's perfect. I mean, hardware is hard. I mean, it's like whenever you try to do something that is interactive, you're gonna run into trouble.
Yeah, but it's more than, I would say, hardware that is failing. It's also people really liking to challenge technology, and then art that is made from technology. I would say even in the beginning of self-driving cars, people would just jump in front of the car. If they knew it was a self-driving car, you would never jump in front of a car driven by a human. You would not. But it's then technology, and then they think that. It should be robust to this kind of unexpected behavior by humans.
But so far I didn't have pieces in public space, so I had only public in a cultural institution or in like safe space. But maybe that's a question to ask Kris, who's done the birds outside. And then there's a more like a possibility or risk of actually misuse. But for me, it has been always really safe spaces. So I think if you go into public space, then it's a whole different space,
Yeah. Okay. There are other. Yeah.
They will be destroyed.
So we cannot put them in public spaces, or. If there's no more questions, maybe a final question to both of you is what is like your big dream, how it should evolve the discipline over time? Where would you like to be in 5 or 10 years? It's maybe a hard question, but so if there would be no limitations in funding or things like this, what would be your ideal realization?
I think it would be just really getting people, students, from education perspective, just working together on projects. And so industrial designers, artists, engineers, and just putting together and let them create.
So I think I'm gonna go the unrealistic way, and that because we were talking with about that with Yael before, is that I wish there was more a movement against the monopolies of really big tech companies, especially like social media companies, which I think is a bit weird that we accept their practices. So that's with me my unrealistic, that we manage to control them in a way, my unrealistic dream.
Okay, thank you very much. Let's thank our panelists.
Okay, so I invite you to stroll around, have a drink, and you will find our other 2 artists in residency, the 2024 artists in residency, Kris and Dewi. You can wave. that are going to be there in the space, especially close to their work, and they will be there to talk about the research project they've been developing through their own residencies at BrIAS during the Sustainable Robotics program. So yeah, thank you very much. And then yeah, I forgot. And then at 8:30, in less than 1 hour, we will be here for the performance of Portrait XO. Thank you.